Okay, this lesson's on some trig relationships, and we'll eventually work into some trig identities as well. There's two main ones we're going to work with. The first one is sine squared theta plus cos squared theta equals 1. Okay, that is called the Pythagorean identity. And if you were to take any angle, put it in, get to take the sine value of it, square it, take that, add the angle, the cos value of an angle, squared, you get 1. Take, for example, 30 degrees. If you were to take sine 30 degrees, square it, plus cos 30 degrees, square it, your answer will end up equaling 1. Now, this can get rearranged, and the two more common ones rearranged is cos squared theta equals 1 minus sine squared theta, and that sine squared theta equals 1 minus cos squared theta. Okay? The second one is tan theta equals sine theta over cos theta. And if you think about it, sine is opposite over hypotenuse, cosine is adjacent to over hypotenuse. Well, when you're dividing a fraction by a fraction, you flip and multiply, right? So you have opposite over hypotenuse times hypotenuse over adjacent, which gives you O times H over H times A. Your H's could cancel out, and you're left with opposite over adjacent, which is tan. Okay, so you have your tan theta equals sine theta over cos theta, and you have your sine squared theta plus cos squared theta equals 1 as being your two main trig relationships that we're going to work with. Now, simplifying, you can do things, all the expanding and simplifying, all the factoring rules, everything that works with algebra, it's going to work with trigonometry as well. So the first thing I want to do is I want to take out a common factor out of 2. So I have 2 bracket 1 minus 1 sine squared theta. Okay, now I want to work with this a little bit, so I know that that 1 equaled sine squared theta plus cos squared theta. So I'll put that in in place of this 1. So I have 2, and I have sine squared theta plus cos squared theta. Oops, don't need that bracket. Minus, and I had that sine squared theta. Now the two sine thetas are going to cancel each other out. Sine squared theta, and then I minus sine squared theta, so I'm going to have simply just left 2 and cos squared theta as my answer. I'm just doing a little common factoring here. It's just basically doing some normal simplifying. Okay, let's take this one right here. I have sine cubed theta plus sine theta cos theta squared theta. Okay, this is kind of a weird little identity here. So let's common factor out sine theta out of it. So if I take a sine theta out, I'm going to be left with sine squared theta plus, and my sine theta has been common factored out, so I'm just going to have left my cos squared theta. Now we know that sine squared theta plus cos squared theta is just simply equal to 1, so all I want to have left is sine theta, because that part there is just going to go to 1. I can do a little expanding here. Okay, so this is a binomial being squared, so it's going to follow the pattern of a squared, 2ab, b squared. So I'm going to have sine squared theta plus 2 sine theta cos theta plus cos squared theta. Now I can rearrange it so I can get the sine and the cos squared theta side by side and have my plus 2 sine theta cos theta afterwards. These two we know go to 1. So I have 1, 2 sine theta cos theta. Now you'll see in a later video that the 2 sine theta cos theta is actually a double angle formula. And so I wouldn't expect you at this point to be able to do it, but at some point it's going to equal to 1 plus sine 2 theta. Okay? But that's kind of, this last line is something a little bit after the fact. It's a double angle formula. Okay, doing some more factoring. I have a difference of squares. A perfect square subtract a perfect square, so following difference of squares. sine theta square root plus square root minus. Okay, and no different here. Here I'm going to have common factoring. Okay, I can take out a cos theta, and that will leave me with 3 plus 5 cos thetas, because cos squared theta divided by cos squared is no different than x squared divided by x. You're just left with 1. Okay, so your factoring rules still work. And then you can have some few more complicated ones here. Show that this simplifies to cos squared theta. So I have a kind of like an equation here, 1 plus 1 over sine theta. Sine theta minus, sorry, that's my dog growling. And equals cos squared theta. And I want to do left side, right side. Okay, so working with the left side, because this is the one that gives me more options, I can use kind of the double rainbow rule. So multiply, multiply, multiply. Now I have 1 over sine theta times sine theta. It's going to give me sine over sine, which is simply just going to be 1. And then I want to have minus sine squared theta over sine theta when I multiply the other one together. And so that's going to, I can do some more simplifying here. Sine theta minus sine squared theta plus 1. And this here, this is no different than x squared divided by x. So it's just going to give me 1 sine left. Now I'm still dealing with just the left side here. I know I have this sine and negative sine, they're going to cancel each other out. So I'm going to have negative sine squared theta plus 1 left in it there. And so I can rearrange this to be simply 1 minus sine squared theta, just switching the order, which we know equals cos squared theta. So therefore my left side equaled my right side, because I wanted to make it equal to cos squared theta, and I just did a little bit of algebra to get it to do so. Okay, so this was the Pythagorean identity rearranged, if you go back to the first slide in this video. Okay, just a quick video on some trig relationships.